Welcome. I'm Stephanie Jordan. I'm the local food program manager at Sustainable Solano, and I'm really excited to have all of you with us today. This is the fourth class that we are doing in collaboration with Republic Services. And the previous ones were on backyard chickens and composting and home composting. And then I did a zero waste cooking demo. And now we are really happy to welcome Melissa Lareau from the Soil Food Web. I also have with us today Marie Knutson from Republic Services. And so what we will do is, if you have any questions, feel free to put them in the chat. After I turn it over to Melissa, she will do her presentation, and then Marie will say a few words about SB 1383 and some food waste laws that are out there. And then we will open it up for questions. So you're welcome to drop questions in the chat. I will be collecting those, or toward the end, we can unmute some of you and you can ask our speakers directly. So again, welcome everyone. And I think I'm gonna go ahead and introduce Melissa. She is the Advanced Programs Manager at Soil Food Web, and she has been managing compost programs for the last 2 years. She has also worked in the fields of public health, technology, nonprofits, food distribution, food service, landscaping, some forestry and urban farming. I feel like she's kind of done it all. And so she will be talking, of course, about the soil and food access, even getting into some really cool things that plants can do that some of us might not even be aware of. And the way that this talk kind of came about is I was talking to Marie and we were tossing around ideas, and it kind of went from like, well, how does the soil affect organic food and the importance of the soil with really just food in general. And then we kind of started talking about health. And at some point we were like, wait a minute, all of these things are connected. Let's see if we can find somebody who can just kind of speak to all of it. So with that being said, I'm going to hand it over to Melissa.
Hi, everyone. Thank you so much for having me. I'm so grateful for the opportunity to talk about some stuff I really love. I know time is valuable, so my goal is that for folks who are really familiar with this, that you learn something new. And if this is completely new, that you get kind of some tools and tips for things that you might want to investigate further. So without further ado, we're going to talk about, there's an introduction, so I'll tell you a little bit about myself. I want to talk about data. Part of the reason I like data is that data is a way to overcome emotions and opinions. Data really tells a story. And so we'll look at some data, but really the bulk of this presentation is about solutions, which is something that I'm really into, and solutions abound. So we'll talk a little bit about biodiversity. We'll talk a little bit about soil biology. We'll talk about compost, the reason we're here. So compost as a remedy. One of my favorite techniques, phytoremediation, a little bit about my business, Dirt Revolution, and some exciting updates, SB 1383. So without further ado, I'm Melissa. My work lives at the intersection of soil health, food, and environmental healing. As Stephanie mentioned, for the last 2 decades, I've been pretty busy. I have a master's in landscape history and have worked in pretty much every section that touches the earth and landscape. And what I found is really interesting is that while those industries seem siloed, really what they're doing is all engaging with land. It's really the same problems that they're facing. And so my key areas of focus after 20 years are soil health, soil consultation, thermophilic compost, which we'll talk about today, vermicompost system setup, which is really worms, food access, phytoremediation, soil biology and soil chemistry, fruit trees, and medicinal herbs. So let's talk about the data. So we know things are not working. And when I say data tells a story, it tells us that things are wrong. So pesticides cause about 200,000 poisoning deaths a year, 99 of which are in developing countries. We also know that insecticides are hugely problematic for human health. So the FAO, which is the Food and Agriculture Organization, which is under the umbrella of the United Nations, they've identified that essentially our industrial agriculture is one of the biggest contributors to this problem. So when we look at water, something we all need, our bodies are largely made of water. We're expecting by 2050 that approximately 5.7 billion people are going to live in areas that are water scarce. And even on the flip side of that, for imbalance, that 1.6 billion people are going to be dealing with flooding from the 1.2 today. So furthermore, but by the way, this is the end of the unfun stuff. We'll get to solutions pretty soon. 75% of chronic diseases have their roots in the food that we eat. And that adage, you are what you eat. So now we have, over 2 billion people suffering from food-related diseases. And so I wanted to highlight these various points from Dr. Vandana Shiva's book, Agroecology and Regenerative Agriculture, Sustainable Solutions for Hunger, Poverty, and Climate Change. First of all, if you're someone who likes to read books or listen to books, I cannot recommend this book enough. It really is super inclusive, talks a lot about many solutions, including biodiversity. So here we start to pivot. Here are some of our solutions. So what is biodiversity? I'm sure a lot of you have heard the word, you can understand what it means, but really to dig into biodiversity. Biodiversity is about having a lot of different types of things. So we want a lot of different plants. We want a lot of different animals. We want a lot of different microorganisms. And essentially the higher the diversity, the more we have of those different species, we start to have safeguards in the system that protects. So there's instances where, certain things will perform different functions. And so if one thing goes away, we have other microorganisms to actually provide that. So Dr. Vandana Shiva, if you don't know who she is, again, I recommend the book, but also just to look into her career. She's done this for 5 decades. She's called the Gandhi of grain. She is an absolutely fearless advocate. And I got a chance to talk to her about the book that I mentioned, the 2023 Agroecology. And essentially, what we need to do is we need to have more different species. But how do we do that? So even the problems in agriculture can actually have the seeds of the solutions. So while industrialized agriculture is really creating huge issues, we know that organic agriculture can actually create, and according to this, not only produce, but creates the biodiversity on all levels. So that's really what we want to go to. But how do we get that? How do we make more life, right? The answer is in soil biology. So soil biology, what does that really mean? Soil biology is about studying the life and interactions in soils. And even I'd like to zoom out just a little bit further for soil. What is soil? So soil can be defined as sand, silt, clay, and this is really important, organic matter. And typically in soil, we expect to see things like the whole soil food web. We want to see aerobic organisms. We want to see beneficial nematodes, aerobic protozoa, beneficial fungi, aerobic bacteria, versus dirt. And dirt essentially is sand, silt, clay without that organic matter. So where does this organic matter come from? This is Elaine. I have been so fortunate to work with Elaine directly for the last 2 years. And Elaine is a legend because she has revolutionized the way that we understand soil and soil interactions. And so largely what I want to highlight is, and this will change my perspective on it. I was a landscaper in California. We had a 5-year drought. And for my job, which was supposed to be to care for the plants, I was watching plants die. And I'm super solution oriented. So I was like, there has to be another way. There has to be a better way. And so I found Elaine's work, and it was incredible to learn that there is actually already designed a symbiotic relationship between microorganisms and plants. And what that means is the microorganisms, which I just mentioned some of, nematodes, protozoa, the arcellas are actually one of my favorite. I'll show you a picture of them. The microorganisms feed at the roots of the plant via exudates. And in turn, the microorganisms will actually protect the plant against pests and diseases. So this exists. This is the design. And so when we put something like chemical fertilizers, what's interesting, what we're actually doing is we're disrupting this natural symbiotic relationship between the plants and the microorganisms. And so what we really need to do, this is Elaine, we're actually just in Costa Rica doing a compost workshop for the school. So when the microorganisms are present, they form aggregates. So we have these glues that come out of the bacteria and the fungi, and they start to form these misshapen micro aggregates, and then more glues glom onto that, and then it can form a micro aggregate. And again, something that I think is just really incredible. So for those of you that know clay soil has super small particles, and it can be really hard to have good water flow and drainage in clay soils. Conversely, sandy soils, super big pore size, so water just goes right through. And when you have the aggregates forming with the sandy soil, you get better water retention and more porous. And then with the clay soil, you actually start to create space and drainage. And that's just one thing that those aggregates can do, in addition to fungi actually also helping to do carbon sequestration. So there's so many benefits to actually having this soil food web. And actually another one is nutrient cycling. So sometimes the plants will be able to get things that were previously not bioavailable by that interaction. And so one of the other things to think about is this successional stage of the F to B ratio. So really we start to understand we want all of these organisms, but we want them in the right proportion. We expect all the way to the left, that's a bacterial dominated environment. And really what it's largely growing is bacteria, as you can see. And then all the way to the right, that's a fungally dominated environment. We see a multi-story forest. There's probably tons of different plants in there. So we need to understand how we can move along in succession and have more fungi. And really this starts to be about this divine balance of the fungi to bacteria. So, what microorganisms do we want, right? So this is what I was telling you about. This one in this top left, that is an Arcella amoeba, I think is just quite adorable. They're pretty common in compost. And then just underneath that, you'll actually see some fungal hyphae. So just by that snapshot alone of that soil biology, I know that that compost is headed in the right direction. It's got 2 of the 3 organisms that I want to see. And then in the middle, that is a nematode. I think that is a fungal feeder. So you see the spear, and that is also something I want to see. So nematodes are actually named for what they eat. So bacterial feeders eat bacteria. Fungal feeders will eat fungal foods, right? So, and then predatory is actually the higher level. They actually are eating the nematodes themselves. So when you start to see different presence of different nematodes, that's a really good indicator. The only one you're not really wanting to see, and if you need to, I do recommend going ahead and getting a DNA test, would be a root feeder, because those can be highly problematic. But we're focusing on the groups we do want. So we also want aerobic protozoa. So that's a flagellate. A flagellate, I don't have a picture here. A flagellate is one of the smallest protozoa, and typically has a flagella, so that's thusly named. So it has 1 or 2 flagella, and actually is it using it to motor around. A naked amoeba, so that's kind of like, looks a little bit like a blob, for anyone that reference makes sense to. A testate amoeba is something that's held in a test, can look like a bottle with an opening. And then Arcella amoeba, as I mentioned, is this, which looks a little bit like a donut in the circle, and you see the opening. You can also see the amoeba inside. We also want filamentous organisms. So actinobacteria is not bad. It's an interesting thing. Essentially, it's typically earlier in succession. So it's not quite the dirt, but it's not quite that mid-level successional. And if you're growing something like brassicas, actinobacteria can actually be really good. But if you're wanting to grow, blueberries, if you're wanting to grow some fruit trees, you really want to move the soil in the direction of having more fungi to bacteria. And then ultimately, we don't want to get rid of the bacteria. In fact, that's not possible or likely. What we want to do is we want to reduce the bacteria, because bacteria is also a food source. So, we actually see some really neat diagrams of blooms of bacteria and then blooms of the testate amoeba, that, for example, that are eating the bacteria. So we want the bacteria there. We just want it in the right relation with the other microorganisms. And so this really begs the question, okay, we know we need them. How do we grow them? My favorite, compost. So there are a ton of different types of composting. I'll just give you three of probably the most well-known. So static compost. If you're someone who's fortunate enough to have access to land or property, especially if something's actually quite large, static composting might make sense. So you essentially make a pile and you leave it for a long time, sometimes a couple of years. And it will decompose. Nature is amazing. As long as it doesn't have plastic or petroleum, it will decompose. And that can be totally great. Vermicompost. So for folks on the flip side, if you don't have a lot of space, I was a city dweller myself. I did tons of vermicomposting in New Orleans and in San Francisco. So we also call this cold composting because there's no heat that we notice generated. And it's great for small spaces. So if you're someone who lives in an apartment or just don't have access to land, vermicompost is great. There's a seminal work called The Worms Eat My Garbage, which I also highly recommend. Thermophilic compost, and this is what we are going to talk about tonight. So thermophilic compost, as the name implies, is hot compost. And really what we want to do is we want to get the starting materials to be hot enough, long enough, above the minimum temperature of 131 degrees Fahrenheit. And this is really appropriate for commercial size properties, larger scales, but don't be deterred if you're a home gardener, because it is completely possible to make this kind of pile at home. It is complex. So wanting to talk about the nuances. Here we go. So the nuances of compost. So thermophilic compost has different ingredients. So for those of you that have made compost before, you may be familiar with, browns, greens, high nitrogen. To make really good thermophilic compost, and in particular, compost that like Elaine has created, it's actually quite scientific. And so I will spend a decent amount of time here, but I want to be clear that, it's an iterative process. A compost recipe, if you're someone who's like a home chef or even a professional chef, a compost recipe should be like a recipe you test over and over and over and just make it better and better each time. And in fact, it is unlikely that the first time you make compost, it's going to be successful, because like a beef bourguignon, there's a lot of elements. You have to be really thoughtful. So I'm going to go over some of them, but just to highlight. So greens are really important. They are going to help sustain the heat. They are not going to create the heat, which is really, really important, but they are going to help sustain the heat. And so on the left here, if I can get my pointer, here, these are just green leaves. So you can get the greens in a variety of manners. I've cut my agapanthus in my front yard. A note on that, you want to make sure you shred it down and not just have long leaves, but that's something that I learned by making it. So there's some green leaves here. And then on the right, that's just grass, which is a pretty common greens. You do want to make sure you cut it when it's green and not when it's brown and dyed, because that will no longer be a green. High nitrogen. So this is really what is creating the heat in the pile. And so sometimes because greens have nitrogen, people may think, well, can I substitute high nitrogen for greens? And you can't. They serve different functions. They, in fact, are collaborators, if that's a helpful reference. So the high nitrogen is really going to provide bacterial food. It's going to be the majority of the heat. And then the general rule of thumb for proportions is that whatever the relative percent of the carbon to nitrogen ratio is, for example, this in the middle left is horse manure. And so if I'm going to use horse manure, and let's say I estimate that horse manure at a 15-to-1 carbon to nitrogen ratio, then for that specific recipe, I'm going to use about 15% of horse manure. And then another rule of thumb is typically for greens, you use about 30%. We actually don't budge on that. You want to really have that 30 be pretty consistent. So for example, if I use the high nitrogen at 15%, for the horse manure and 30, the remainder is going to be my woody. And really, out of all of the things that are the most important, accurately assessing the carbon to nitrogen ratio of your high nitrogen is really going to be probably what makes your pile successful or has it failed. And also, just as a way to reframe a fail, as long as you learn things, you didn't really fail, but it can be a lot of effort to gather the materials. So I completely appreciate that you'd want it to be successful. So making sure you have as accurate a C to N ratio as possible is going to help you get set up for success. Some other things to think about. So for example, actually even here on the left, I have horse manure, which is an animal high nitrogen. And on the right, I have cracked corn, which I purchased at a store. And so you can do plant-based high nitrogens. For example, seeds. So cracked corn is an example of a seed. You just want to make sure that the shell is cracked and that the inside is exposed so that the bacteria will be able to access it. That's how it's going to break down and be able to be decomposed. If you choose to do animal manure, for example, you want to make sure there's no deworming or antibiotic, because those will absolutely impact the biological growth, essentially. And so if you go to source the manure, really important questions to ask are, what did this animal eat? You want to go for grazing animals typically, because that's a way to reduce the likelihood of pathogens. And then also we want to understand, when was the manure collected? But we'll get a little bit more into that. Other great plant-based nitrogens, high nitrogens, for example, are like legumes. You just want to make sure the legumes have nodules, and alfalfa is one of my favorites. So woody, for the woody, the recipe, as I said, is the portion of whatever is left over. And the woody is not going to make things hot. The woody is actually kind of like your savings account for your fungal food later on. So as we get into the maturation phase, the fungal foods of the leaves on the right, and I have some wood chips on the left, those are what we're going to use to actually grow those fungal communities. Because remember, we want as big an F to B ratio as possible. And really what we're doing with compost is we're inoculating it. Okay, so as I mentioned, thermophilic compost is hugely complex. And so to simplify to the point where it makes sense and is more digestible, I like to think of compost like a good story. And so there's a beginning, a middle, and an end. And so for the beginning, we want to make sure we're sourcing, we're storing, and we have adequate preparation. What does that mean? So where am I going to get these materials? How am I going to get these materials? If you're someone who maybe doesn't have a car, that's something to think about, right? I used to be a bicyclist myself, and I would pretty happily transport gardening tools, but I have to tell you, I have not as of yet been able to lug a bale of hay, for example, on my bike. Like I might need to borrow a truck. So you have to figure out not only where are you sourcing these materials, but how are you sourcing these materials? And then in the middle, and this is actually probably what gets the most attention, the thermophilic phase. So actually when your pile is hot, you've put it all together, you've done the work, and for about 2 weeks, you get to actually see this pile heat up, hopefully. You hope the pile heats up multiple times and you get to turn it and re-aerate it. And then when you've successfully hit the time turn temperature and the pile temperature goes down, it will go to ambient. Then you enter the maturation phase. The note for the middle phase is that you do need to take temperatures daily. So you have to plan ahead. You can't, go on a camping trip in the middle of your thermophilic compost pile because you need to have those temperature readings within every 24 hours. And then the end, and this is to me so important because I've seen people just be like, okay, I did it. Oh, thank goodness, I finished the pile. No, not so. This is why the end is just as important. And so after, let's say it takes you 3 months to source materials, and then it takes you 2 weeks to actually manage the active pile. The worst possible scenario is that you'd walk away and not properly let it mature. And so at the end, and the reason why it's its own phase, is you have to actually make sure that you're putting it in the proper place. You're giving it the right amount of moisture so that you do create that great F to B ratio in those fungal communities and the protozoa we want to see. So, all right, the beginning. What is local to you? So when you start making compost, and another note is when I say compost, I'm not talking like a cute little like sprinkle of something on I'm talking about a 5-gallon bucket pile to up to an 85-gallon bucket pile. That's a pretty significant amount of inputs. And so when you start sourcing these materials, things that start to make more and more sense is like, what's local to you? I happen to live in Sonoma County, so I have access to a lot of feed stores. That's not true for everyone else. Also, do you want to buy? So for some people, buying materials is just not possible. That's okay. There are alternatives. You could grow, you could forage. If you happen to have friends who have property, or people who have property and they don't mind you coming to harvest it, I've heard someone else say, and I agree with this, you end up paying for it in one way or another. And what does that mean? If you're harvesting and you're foraging, that's 7 hours of your time, right? And lugging and hauling. So that's just something to think about. And especially the more you make compost, you really want to make sure that it's relevant. So can you properly store your sourced ingredients out of the elements? Yeah, where are you going to put them? So if you're someone who's space confined, let's say you do all of the hard work to source those materials, where are you going to put it, right? You need to have a place that is cool and dry and not going to, essentially, we want to make sure that the decomposition in particular of the green and the high nitrogen materials are stopped. So you can put it in your freezer. That's actually, I call it like lazy storage, but it's very effective. So if you have a big enough freezer, you can go ahead and put it in your freezer. If you can't, you can dry the materials, but you want to make sure that the high nitrogen in particular, as well as the green, stay as decomposed as possible. Otherwise, you're unlikely to have a successful compost pile. So let's say you do all of that hard work of sourcing, storing, and drying. Now is the exciting part. So for actually making the compost pile, I will say, depending on your own physical limitations and abilities, it's a lot of work. So I was going to make an 80 bucket pile last winter, and I couldn't find enough people. I actually wanted at least like 5 to 8 people, and I couldn't get enough people. So you have to be thoughtful of how much work these things take, but you can get community and even help, and that's can be actually a really pleasant experience. So thermophilic compost is essentially compost that's hot. We're looking for above 131 degrees Fahrenheit, or if metric is better, 55 degrees Celsius for specific amounts of time. And this is its own thing that we could talk about for hours. So there are different time thresholds, but really if you just distilled it to hot enough, long enough. And what we're looking to do is to heat up and kill weed, seed, and pathogens. That's really the point of hot compost. And so when keeping things in mind, you really need to make sure that you have adequate time to build and manage the pile. So the thermophilic stage is typically 10 to 14 days. And something to consider is this is not your timeline. I think I've watched people get very confused by that. You build this compost pile and then you're like, great, okay, well, I have this obligation with the kids, or I have the compost. That doesn't matter, right? Like, you have to be aware that this compost pile that you've created has a life of its own, and it's going to stay hot depending on how much nitrogen and greens for the amount of time it's going to stay hot, and it's going to go down to ambient when it goes down to ambient. So I'd say enjoy the ride, right? Like, treat it is biology in action. You're watching a microorganism container happen before your very eyes. So like I said, super important to have sufficient support and the physical energy to build and manage the pile. And this is typically what people consider the most fun. You get to do daily temperature readings. So at the end, so the thermophilic compost pile end. So we want to make sure that after all that hard work, we really take care of it. And why have this little note on the bottom that says, remember, we want to grow fungi. And fungi, this is something actually I've worked with plants for about 20 years, can be really helpful just to remember what was the natural environment of that thing we're trying to grow. And so for fungi, they like it to be moist, dark, and aerobic. So if we can recreate that environment for our maturing compost, so you see here, I have a picture of my cute little greenhouse. For those of you that were here last year, we had 3 atmospheric rivers, which is a lot. And when you have the compost go down to ambient, the absolute worst thing you can do is drown it with water. It doesn't need the same amount of water when it's in maturation. You actually want to lightly mist it, depending on how hot it is, just to kind of keep it like a coat, to keep the moisture in so that the biological processes are happening. But you do not want it to be saturated. So I actually had to build that to keep it protected from the wind and the rain. So keeping it protected is really important. Okay. So I thought it would be fun to actually show you compost for real. So because making compost can be quite a lot of effort, at the school in particular, we name our compost piles. So for those of you that speak Spanish know what this means, but after a couple, each compost pile is different. So I called this Esperanza because I really hoped it was going to work. And it did, which was great. I was really pleased. I dealt with kind of an insane amount of environmental conditions, all of which can affect your pile. So this was in the winter. So I dealt with freezing temperatures, snow. Where did that come from? That was hilarious. Multiple rain events, wind. And so that's actually on the right. The reason I have that picture is that's what that pile looks like, kind of all wrapped up, to make sure that I can maintain those heats so I can hit all of my time turn temperature requirements. And it did, actually. I was really pleased. This compost pile did great. It was alfalfa, wood chips, leaves, and some hay. And then kind of putting it all together. So this is kind of what we talked about originally. Why are we growing? Why do we have compost? We have compost because we want to grow the microorganisms. And so that compost, Esperanza, I checked it in September, and here are the numbers. So we typically want, for what is called biologically complete compost, we want 135 micrograms per gram. My compost was at 271, so it was way over. I had done the right thing where I'd grown the compost. However, and this is where compost is so fun and biology is always changing, the bacteria, so that if you notice, 135 micrograms per gram, and the bacteria of 135 micrograms per gram, that's going to be a 1-to-1 ratio, just to bring it back to the F to B. So that's what it's recommending, is a 1-to-1. However, the bacteria was kind of off the charts. There was a lot going on. So I think I caught it in a bacterial bloom. So there was also a lot of protozoa, which you can see. So the protozoa, if you go down to here, They recommend around 10,000. I had 900,000 protozoa. Plenty of bacteria, plenty of food. So that's where this, I thought whether or not to keep this, because I was like, that doesn't necessarily look good. But I think for those of you that actually make compost, it's not terrible. It's just, getting that balance is a thing. And that's why I chose to keep this, is that, I'll check this now, and I'm willing to believe that bacteria has gone down and my fungi has gone up. So it's really like paying attention, doing the soil biology assessments, seeing where the numbers fall. You can see I had great amoebae, great flagellates, and even I had plenty of nematodes. So overall, the compost was good. I just needed to reduce the bacterial population and allow it to mature a little bit more. So let's talk about something, and Stephanie mentioned it. I don't know if a lot of people know about this, and I love it, and I think it is absolutely, truly transformative. So one of the final solutions I want to talk about is phytoremediation. So what is phytoremediation? Great question. So essentially, phytoremediation is plants being able to degrade, remove, or render harmless toxins in the environment. In my opinion, I think this is Mother Nature's forgiveness policy. So no matter how many things we've done, there is actually a plan. And I actually was introduced to phytoremediation when I lived in New Orleans before and after Hurricane Katrina. I had a bunch of community gardens, and there was not a lot of help from the state or government to help. And so I used plants, like a lot of other folks, as an affordable and effective way to actually make the landscape something I wanted to eat out of. So just to highlight a few, I took 3 of my favorites. So that was actually willow in that little picture. So willow trees do remediate, as do poplars. So poplar is amazing. They can take chlorinated solvents, such as trichloroethylene, and can remove it up to 95%. An organization, Phytobot, that a Canadian database states that poplar trees can degrade petroleum, hydrocarbons like benzene, toluene, and oxaline. So this is just really incredible because essentially, for a lot of folks that I've met in my work, I think there's some level of defeat, like, oh, well, things are just toxic. And it's like, we can change that. Just like we can make compost, we can actually use plants to help heal the earth and remove some of those toxins. You'll notice in a couple slides that actually the logo for my business is a sunflower. And part of that is because it's one of my favorite remediators. So it's beautiful. It's a great winter flower, and it has the ability to remove things like uranium, uranium and other heavy metals, zinc, lead. So if you have children, you're probably heavily been warned for the dangers of lead poisoning. We also now see a lot of arsenic in our soils, and sunflower is a hyperaccumulator, where in instance it'll actually hold the toxins to it. And so if you remove it and you get rid of it, the toxin is now attached to the sunflower. It's not attached to the soil anymore. We don't have to eat it. And then mustard. So thinking practically, it's not always summer. So if you want to do remediation, what if you want to do remediation in the winter? Brassicas, and this is where brassicas and mustards shine. They're a great winter plant. I put this here because I don't know if people know it, but lots of people have heard of Chernobyl, but I don't think people are aware that they used mustard to remove a lot of the radioactive material. And so that's cited there. Mustard can remove 3x of cadmium, lead up to 30%, 48% of selenium, and additionally helps remove zinc, mercury, and copper. So mustard's awesome. And then actually, as I mentioned, so this is my business, Dirt Revolution. And you can see with the sunflower, so that's one, because sunflowers are a great remediator. And then 2, hopefully you learned earlier in the talk a little bit about nutrient cycling. And so this idea that dirt becomes soil if we just restore our natural cycles. We get back to nutrient cycling. And so after 20 years and broad strokes, and just to bring it all together, I think you need to test the dirt. And what does that mean? So I liken the idea of testing your soil as you would to check your bank account balance. And that's not always fun, but when you do it, you can understand what's there. And so I think a lot of people live in a, I don't know, there's probably some toxins there, or there could be lead. It's like, if you test, you'll know. So I do recommend testing the soil and then use plants to clean it. And then no chemical fertilizers. So this is something I learned from Elaine. That chemical fertilizer, the nitrogen, potassium, phosphorus, is going to actually disrupt your beneficial symbiotic relationship between the plants. And we really want those microorganisms. We want to grow those microorganisms. And actually, the other thing to think about is it makes it easier to take care of the plants. You're going to do less work if you let nature do the work for you. So cover the dirt. As a landscaper, gosh, I can't tell you how sad it made me. I know there's this aesthetic norm of having a completely clear, they call it like debris free, and it's considered clean. That is a terrible scenario for the microorganisms and actually the plants. And if you maybe start to look around, you'll see that the dirt typically looks more white and is actually hydrophobic, which means if you put water on it, water will run off, it won't absorb. We want dirt that looks like this really rich, dark carbon. That means that things happening. So one of the quickest ways you can do is you can cover the dirt. You want to support the life. It keeps it cool, moist, dark. And then also all of that debris serves as food for those microorganisms. We want to put the nutrients back. So we talked about compost, and I'm excited to hear what Marie has to say about the new law. But composting is a great way. If you can't compost, mulch, just even leaving debris. Again, thinking about how plants were created and evolved, plants didn't move, right? Like really think about that. Plants weren't designed to move. And so when we're constantly clearing the debris from underneath them, that debris was meant to be something that was going to be cycled back into the nutrient for a thing that's stationary, essentially, right? So one of the things we can do is we can start to give nutrients back. And then food security. So we didn't have tons of time, but wanted to talk a little bit about it. And in my opinion, food security is having systems in place that support sustainability, time, and energy invested in the development of trees and herbal medicines, as well as annual foods that need to be seeded. And most importantly, you really want to make sure that you have food that you and your loved ones want to eat. For example, let's say you hate Brussels sprouts. I think they're delicious, but you might hate them. If you have a yard of Brussels sprouts and you hate Brussels sprouts, while you may technically have food to eat, I guarantee your soul is going to die, right? Like you're just going to be sad. It's not fun to eat something you don't like. So you really want to make sure that you have food that you want to eat, as well as the people you love. And ultimately, food security is not about growing something in a single season. It's about reaping the rewards of energy over time. And over to Marie.
Thank you, Melissa. All right, there are questions and we'll circle back to those. So Marie, since we're talking about all of this compost, and I know you're kind of like one of the compost providers around here. So feel free to jump in and let us know how all the food waste and the compost is tying together.
Well, I'm sure you've all heard about SB 1383, and statewide, we have to collect food waste. We have to put that out there and have it available to collect your food waste and food soiled paper. And that for Republic Services, one of the places it's going to is our Richmond facility. But if you have all of these people putting their food waste in their green yard waste carts, where does it go after it's ready? So there's also, we're working hard to make sure what we put in is what we bring back. and what we put into our local gardens and our community gardens and our parks and your front yards, hopefully. And Melissa, all the information on the composting was amazing. And of course, like soup, the best compost is what you make at home, right? Because it's fresh and you've done it and you've worked so hard. Well, if you aren't able to do that, we do compost giveaways twice a year, once in March for your spring garden and once in August for your fall garden. And you can always email me. I can put my email in the chat, and I can put you on the list for when those are going to happen. If I specialize in Benicia, but just about every holler has these kind of programs. So if you're in Vallejo with Recology or out in Sassoon, contact your hauler. I'm sure they have those programs available. And what's been happening with 1383? Well, consider that this is the biggest change we've done to protect the earth and try and fight climate change in 30 years. So it's going to take all of us a little bit of time to get used to it. But the other thing is that it's statewide. So all of us all haulers are trying to add reps and add drivers and add trucks and set up the collection. And we have to have 75% reduction in food going to the landfill by 2025. So that didn't give us a lot of time to put everything in place. So if you get calls that maybe a route is delayed, it's happening with all of the companies because we're trying to do this statewide. So everybody's trying to get the drivers, the trucks, the containers all at the same time. We're also, one of the intricate parts of this law is that containers all have to be universal colors. So in Benicia, we had blue for garbage and blue for the big metal containers for recycling, and green for the yard waste in the organics. Well, now everybody statewide has to have black or gray for trash, blue for recycling, and green for yard waste and compost. Which is great because if I come over to visit you in Vallejo, I know where things go. So it is a great idea, but it's a lot of hard work. So we're all trying statewide to get that done. We also have to do lid flips, we call them. We're in your neighborhood in residential areas, flipping lids to see how things are going. What do we need to educate people on? And you may have been left a tag, we call them oops tags, that it's not a fine or anything like that. It's just educating the public that you can't put styrofoam in your recycling and no plastics in the organics because plastic doesn't break down and turn into dirt. And the big part too is that any food that's edible, like Melissa was talking about, you have a yard full of broccoli. You can donate that to the food banks locally. There's the food bank of Contra Costa and Solano. There's Food is Free Solano. There's a lot of different organizations, which I'm sure you can access through Sustainable Solano and find them to donate that food. We don't want it to go in your green cart. We want it to get eaten. So all of the haulers and everyone in general is trying to work on that as well. And the last thing, of course, is education. So you'll see a lot more newsletters going to homes and a lot more classes and presentations to help learn how to fix the soil, how to live more organically, and how we can fight climate change. And that, of course, is the ultimate goal, which is through our soil, creating better food, better plants, better climate, and we'll all be better off. So if you have any questions, feel free to put them in the chat, and I'll be happy. I'll put my email in there as well if you think of something later that you wanted to ask. And back to you, Stephanie.
All right. Thank you, Marie. So there were several questions that have come in. So one thing that actually Marie was asking earlier, when you were going through the greens and the nitrogen and the woody parts, and I'm going to spotlight you, Melissa, in a minute, but the question was, what are some examples of the nitrogen? And I believe one of them was the corn, but are there others that you can speak about?
So specifically for seeds, you mean? Sorry, will you say that one more?
I think, Marie, were you asking about just nitrogen for the soil in general?
Yes, if you were saying there was the three main things that you put into your compost pile, what examples of nitrogen were?
That's very helpful. Okay, so yeah, manures. So horse manure is really great. Why I like horse manure is it has an ability to get hot, but not too hot. You want a lot of the Goldilocks, so that just right. You want it to get super, super hot. You want it to get hot and stay hot. Horse manure is one. Goat manure, cow manure is a little tricky because it tends to be liquid as it's being excreted and then becomes solid. Also, depending on what the cow grazed, that can actually create a really wide or variant C to N ratio. So for that, I also like the plant-based. So alfalfa or lucerne is a legume, which is just fantastic. It's super hot. Beer mash, actually, so if you live in an area that has breweries, beer mash can be a great resource. A note on beer mash is it's stinky. So actually, I think most people think that compost is stinky. I hope you all know compost actually should not be stinky. That means it's bad or it's gotten anaerobic. However, the exception is when you're making compost with beer mash. Beer mash is pretty stinky, so that's another high nitrogen. Grape mash. I have not used grape mash, but certainly in this area that could be interesting. I'm not sure if it technically. I'm going to look into that. I think grape mash is really. I'm curious. I have not heard of it as of yet, but beer mash is definitely a thing.
And related to that, Susan was wondering about waste from chicken coops. Could that?
Great question. Super great question. Chicken manure is absolutely a great source of high nitrogen. And actually why I love this question is it highlights bedding. So as I mentioned, the complexity of making compost, you need to really take in contextual factors. So if, for example, that chicken manure is all rolled up into some hay, you actually would need to include the hay as part of the browns in your pile. And then also guess essentially how much actual chicken manure you have. A note on that, so that's something to think about with what you use for bedding for your chickens. Hay is great. Wood shavings is not, because they have a tendency to become super compressed. So that's actually the first thing I would check is what is the bedding of the animal. And shavings can be a nightmare. Actually, in Costa Rica, we did a pile with the wood shavings and chicken manure, and it was successful, but it took work and it was tricky. There's lots of nuance of like, it doesn't look shiny. It's like sawdust, similar is kind of a nightmare because it doesn't really look shiny. So it's hard to tell the actual moisture content, and moisture will make or break your pile. But yeah, good question. You absolutely can use chicken manure. It starts out super hot, and then as it ages, it gets colder, or the C to N ratio widens.
And then people are wondering how you measure all of these things in the soil, from the nematodes to the fungi and the bacteria. Is there a particular method?
Yeah, also such a great question. So the school, and actually I'm a lab tech myself, we have a program that teaches you how to become a certified lab tech for soil biology. So actually my microscope is literally within, like, to the left, I can almost touch it. I do microscopy assessments for soil biology. That's actually what I was showing you. So that picture of the compost pile and then the data, that's what I did. Was I took a slide, we have a sample collection process, and then you take a drop on a slide and then you look at it under the microscope. For good scientific due diligence, you typically want to do 3 replicates. But yeah, that's what you're doing, is I'm actually looking under the compound microscope and identifying the nematodes, the arcellas, etc.
And if you don't have your own microscope,
Sure. Well, there's folks in the area. So depending on if you want to learn it, a lot of, and even like compost, what the best path for you, it really depends on what problem you're trying to solve. So if you're someone who's a farmer and you want to, learn this for yourself and actually see what's going on with your soil, maybe it might make sense to get a microscope and take a class. If you're someone who's like, I do not have time nor the interest to do soil biology, then you can hire someone like me or other folks to do that for you. And, we're happy to do it. And it actually comes with that printout like I provided.
So on the topic of the phytoremediation, people are wondering, what do you do once you've got the sunflowers and the mustard plants and they've grown and they've collected the toxins? Then what do you do with them? Can you chop them up and use them as a cover crop, or do you have to get rid of them because they're quote unquote contaminated? How does that get dealt with?
Yeah, that is such a great question. And I hate to do, but the most accurate thing I would say, it depends. So for something like a sunflower where it's a hyper accumulator, you may actually have to incinerate it. You may have to actually make it toxic waste, unfortunately, but it is what it is. For other things, they actually will off gas. So one of the things with their actual biochemistry is they can convert that really toxic or terrible thing into something that's not. And that's where, to me, like, the world of phytoremediation is so interesting because there's different ways. Sometimes plants will actually hold the toxin. So the toxin doesn't change chemically, but it also is no longer bioavailable, meaning like the things in the immediate environment can't access it. So there's a couple different ways that plants can do that. And to fully answer your question, I would say what makes the most sense is you'd want to do a soil chemistry test to understand how much of whatever toxin and or what toxins are present. Then you do your planting rounds, and then you do more tests. So essentially you're doing like a confirm. Okay, where are we at on the presence? Oh, great. Like sometimes it can be as quick as 1 season. Sometimes it takes numbers of planting. But for me, like if you're really thinking about it, you're moving in the right direction. And I think with a lot of this stuff, that's really where you have to start, just keep moving in the right direction, and eventually it'll be good.
Okay, next we have some more like composting questions. So Phyllis says, I hauled a lot of different loads of compost and soil into my yard, as well as turning over what was there. Which portion of my yard do I test, or does it blend after a few years?
After a few years, I would say biology has taken, it's no longer new. So yeah, probably at that point you could do a representative sample. I would also check that compost. So, because one of the things that I'm the most excited about with this new law is it's also forcing us to really get clear about like what good compost is and why we have it and the uses of it. Historically, compost could be anything, like essentially that's decomposed. So I would also highly encourage you, if you have a microscope or know someone who has a microscope, to check the quality of that compost before you put it in your yard, because you may just be adding a bunch of bacteria, which we know bacteria is there, right? But we really want to grow the fungi. We really want to grow the protozoa.
And someone was asking about, kind of related to that question, is the compost mixed into the existing soil, or can it just be left on top?
That is a great question. So I really briefly talk about it on one slide. You can absolutely, once the compost is matured, you don't want to put hot or really new maturing compost, because it might actually have it might burn the plants. So that's actually a concern. You really want to allow it to go through its process and have the higher fungal to bacterial ratio before you put it on. But one of the things actually I learned at the school, and it makes so much sense if you're applying over a larger like place, essentially if you've got acres or hectares, actually extract. So all of that work you did to make that really, really, really great compost, instead of being like, okay, great, I can cover half of a quarter of an acre. No, right? Like you actually can put the compost in water and extract it, and you can get that same compost to go over an acre or multiple acres. So with extracts, it actually goes a lot further. And I highly recommend that, especially since what you're doing is you're inoculating. That's really what we're doing, is we're trying to reestablish or revitalize the presence of those soil microorganisms.
And is that also called a compost tea?
Another fantastic question. So technically, the difference between a tea and an extract, the tea is with an additive. So you actually feed the tea. So you would definitely do it in an aerated environment with some kind of bubbler. And then depending on what organism group you want to grow, so like let's say typically you want to grow fungi, but you may want to grow protozoa, you would actually test different fungal foods. So molasses can be a food, kelp can be a food, and you would see, again, it's pretty scientific. You'd track different experiments with the food and the extract. And then when you finally like your compost recipe, you've tweaked it and you've made it really good, then that's when you would do the tea.
Okay, a couple more simple questions here. Someone's wondering about organic fertilizers. Are those okay to use?
What do you mean by organic fertilizers?
I don't know, Tamara, do you want to unmute yourself, or maybe I need to tell you to unmute? Let's see here. Are you able to unmute? Let's see. Can't seem to find my participant thing here. Or if you want to put it in the chat. No, I don't see. Hold on. Let me close the chat.
I think she has to be a presenter to unmute her.
Okay, hold on. I'm gonna see if I can find her here.
Or she can put it in the chat.
Yeah, I think I just asked her to unmute. Hopefully that worked. Maybe. No. Okay, maybe put it in the chat. I don't know. My Zoom. I don't know why that's not working.
I did not ask that question, but I would also like to know, I work as a student assistant for the Cabrillo Community College Organic Farm, and up there we do compost, but we also do fish emulsion, and like Grower's Secret is a kind of a powder, and you can get it in different formations of, we use a lot of 1600 for nitrogen, and then also corn steep, and that comes as a powder, and we mixed it up with water and put it into the irrigation line. So those are like the three main ones we use, to give some examples. Yeah. What are your thoughts on those?
That's super helpful. So I'd say the kelp, I think the kelp is great. It can grow, actually fungi love a lot of the ocean products. So the kelp, the seaweeds, and I would consider those completely biological amendments and no problem. Some of the other stuff, and that's why I asked, is I would be really curious what the actual ingredients, because, and just to give you an example of something different. So neem is a wonderful natural pesticide. And if you buy neem, you can look at the product, and what I found more often than not, when you look, it says 99.06 other ingredients. And so I just want to make sure whatever you're saying, I don't know what is in all of it, but kelp would be fine if it's typically like natural, meaning truly nature. When you're given the description of the NPK reissues, that starts to sound to me like a chemical fertilizer, but again, I don't know if I don't see it. So sounds like it's probably fine. But the note I will emphasize on that, if you really get the life rocking and rolling in the soil, you don't need to do that. That's, I mean, literally even disease. I had something on one of my verbena. I put compost all over it. all of the lead, like it's so incredible what actually the difference is. Like my water goes further. I don't have to do things to take care of my plants. They sort of are taken care of. But that's a great question. Kelp is good. I'm not sure about the other ones because I can't read the label.
Thank you.
And then Barbara's asking for older adults that have like little physical ability and just need to do things more easily. That's, easy to get the microbiomes back into the raised beds. Do you have any suggestions? She was also asking about, is the compost that they get from the compost giveaways from Recology or whoever, is that a good place to start?
So absolutely appreciate physical limitations. And so, yeah, there are options. One of my favorite is lasagna gardening. So lasagna gardening, you want to put some cardboard down, you're going to put some compost and then mulch. And that does wonders in and of itself. That's pretty easy. I mean, I'm not going to, the bag of compost, you may need help, right? So just depending on where you're at, you may need help, but that's a pretty straightforward one that requires less. And then even less effort is actually the worms. So just having some red wigglers, and the big difference with we didn't go too much into the vermicompost, but the big difference with the vermicompost is if you're looking for that F to B ratio, the majority of our kitchen scraps, which is why that book, Worms Eat My Garbage, that's actually going to have a higher bacterial dominated, because it makes sense. It's the food, right? The food is more bacterial. So it's going to produce a more bacterial dominated worm bin. So something you can do is you can actually feed your worms carbon-based food, which when I heard that, like, I don't know why that blew my mind, but it did. So one of the gentlemen I've worked with, Eric Feeler, he's a consultant out in Utah. His worm bin is 8-to-1. 8-to-1, because he feeds the worms carbon-based food. He feeds them compost, he feeds them mulch. And they produce more slowly, so that's something to keep in mind. But in terms of your physical output, you could just have a little bin. You just need to make sure the worms are wet enough to do their reproducing, and then you can leave it. Like, especially if you're feeding them carbon based food, you wouldn't need to really touch it except to just make sure that the worms are moist. And then in terms of the free compost giveaways, I would just say, Marie might know more, but I would check it under the microscope.
All right, there's
if I can say that,
go ahead, Marie.
if you don't have a microscope, they do test the compost before it goes out to the giveaways. And if you're using it fresh, it's fine. It's certified that they can't send it out unless it's certified. And it goes to a big compost facility where they have aerators underneath it and are wetting the top and watching what's in it. The one thing that I've seen people make a mistake is they'll want a whole bunch. They'll bring in their 96-gallon green cart in their truck. But if you don't use it in, say, 6 months, a year, and get it in the ground, then it's going to start getting dry. And when you mix it in or put it on the top, it kind of permeates. The water more runs off. So you just want to use it while it's fresh and it is tested.
Thank you for clarifying that. Someone has a question here about the compost pails and just kind of how that works. She says, I think she meant to say compost does not stink. That little compost pail the Recology gave us worked well at first. I cleaned it each time, but then the last 2 times within a few days of adding vegetables and coffee grounds, it's turned smelly. It's turned to smelly bacteria looking like spidery nets forming. Spidery net formations. What am I doing wrong? I don't know. Is there something? Maybe that's right. Maybe that's working. What are those things?
I can tell you because I have a compost bin and we empty it once a week, depending on what we're cooking, twice a week. And there's 3 people in our household. If you don't use a compost bag, just line it with more newspaper, or just like if you were building a compost bin, some dry leaves and that to absorb some of the moisture. You can also put your compost bin in the refrigerator to keep it cold, and then just empty it on your service day, or empty it more often. But it shouldn't smell really bad unless you've left it quite a long time, quite a while.
Did you have something to add, Melissa?
I did. So that's where I was going to say the lazy compost storage technique of freezing. So if you happen to have freezer space, and I have absolutely, I'd say, not gotten in trouble, but not been on the best my partner's happiest list by having compost in the freezer. But it's a great way to stop the biological process. And if you have a deep freezer, that's another way. So it won't get stinky because you're literally freezing time, right? Like you're stopping the decomposition. So that's why freezing can be a great alternative as well.
I want to backtrack a little bit to the worms that you were talking about. Barbara was asking, is putting bait cages full of food scraps in raised beds for worms worth all the effort? I don't know if that got answered. I was kind of looking at monitoring something else. So do they put out enough worm castings to really make a difference?
Yeah, I mean, worms are really amazing. I'd say putting it just because, so raised beds are their own thing. There are systems of vermicompost where you can actually plant into the ground. So without getting too nerdy and into the actual like nuance of different worms that appear at different layers, there's different types of feeders. So there's litter feeders, which are more top feeders. So most often you'll see those in worm bins. But there are ways you can dig into the ground, and you'll start to get those middle level worms. So you'd actually have more diversity. In terms of just a raised bed, I think the harder part of that, and I have it myself because I love nature and I create ecosystems. Worms are delicious. I mean, delicious. So raccoons want them, foxes want them, all rats want them. Like, they are delicious. So having an actual worm bin of some kind, whether it's inside or outside, and also putting something heavy on it, like genuine cats, like literally love things with worms. So putting weight on the worm bin will essentially make sure you have that worm population, because I have absolutely fed my friendly creatures in the area with my worms for sure.
That's great. There's a question about soil tests. That's from Marie. The kind you buy at the store, are they worth it? Do they work?
So they do work, but they typically tell you pH. So it's what are you wanting to know? So there's different types of soil biology tests versus soil chemistry tests. Soil chemistry tests, I think of as like a dim sum menu, if that makes sense to anybody. You're choosing a lot of options. Do I want organic matter? Do I want to know if there's arsenic? Do I want to know my nitrogen, etc.? But when you say at the store, typically those are going to tell you pH. pH isn't bad, it's good information. It is in no way the complete picture. So that's where I think in terms of like, if you're going to spend some money, and actually in terms of chemical soil testing, universities are a great resource for that. They tend to be a little bit more affordable than commercial. And so it might make more sense to save some dollars and actually just do some research on your property or the land that you want to test, to understand what is the most likely, let's say if you want to test for heavy metals, what's the most likely heavy metal in this area based on the land use. That's when you have to actually do some good detective work. But yeah, they're not bad. They'll usually do pH, and it's just a very small portion of the overall picture.
And speaking of the heavy metals, there's another question about phytoremediation. What area is covered by, for example, one sunflower plant? Like, how much area can a plant, detoxify, I guess is the word.
Yeah, I'm happy to like look into that, and maybe I can find some resources and share that back with Stephanie, and she can share it with the community. Again, typically what we're looking at is the proportions. So how much contamination are we looking at? And that is actually where I would start to figure out how many plants. Rather than like, I need this area, it's more like, what is the concentration of the heavy metal or toxins in that area? and then I'll make my plan accordingly.
All right, there's questions about the maturation phase. How long does that phase take? And then they would just like you to expand on that phase. Let's see, it's the first time somebody's heard about it. Yeah, how long is it? Do you add other stuff? How do you know when it's not too hot and has that good ratio of the fungi to the bacteria?
You just said a lot, so I want to try to cover all of those points. It shouldn't be hot. So that's the first most important thing. If it's in the maturation, in order to technically be eligible to be in the maturation phase, it needs to be down to ambient temperature. So it shouldn't be hot. That's part one. In terms of how long it takes, and this is where actually, like, to me, I've been doing this for a long time. You never stop learning. There's so much nuance to it. So I had a compost pile the year prior, same exact location. It matured within 3 months. Yay! So I took that information and thought that Esperanza, which I showed you, would also mature in 3 months. Oh, not so. And the reason being, that little structure I showed you, in order to build that structure, I actually cleared a little bit of branches above. And then I was like, okay, so my last compost pile took about 3 months. I did a soil biology assessment around 3 months. And I was like, oh, weird. I'm not getting the numbers I want. So what I did is I went outside. I'd say a lot of engaging with nature, look at contextual clues. That is huge. So I went outside. I was like, okay, what's different? And I was like, oh, there's more sunlight coming through. There's more sunlight here. And that's why I made that note. You want to replicate the environment that fungi grow, which is like forest floors, which is shaded, it's moist, it's aerobic. So what I did was I actually covered, I have some ute bags, I covered so it's breathable, but it's darker. I made sure to mist it less. Anyway, so you make adjustments. So all of that to say, it can be as little as 2 months. It can take as much as 8. A little bit of what Marie was saying, you don't want to let it go too long because it'll actually start to become, it's dirt. It's no longer compost. You've essentially like allowed it to cycle through where it's dirt. So you want to hit while you have the most fungi, because the fungi will be consumed. Everything's living. Remember, this is biology. So you want to hit those time windows at the right time. So it's like the most fungi with the other organisms present. Did that answer all the questions? There was a couple parts of it. Oh, what does maturation look like? So you want it to be covered where you live. So as I mentioned, I had a colleague in Utah. It's hot in Utah, right? He has to mist that compost twice a day. He's got it on pallets. He's got little canvas covering. And so that's one way. If I have a colleague who's in, colleagues in Costa Rica, it's humid, it's raining daily. Ambient moisture is going to get sucked in. You actually probably want to not water. You want to like check the moisture levels, especially since when the compost pile is no longer actively producing heat, you just want to give it between 30 to 50%, usually more 30 to 40. So you have enough water for the microorganisms to thrive, but it doesn't go anaerobic. So hopefully that's helpful. The mist setting on your the nozzle is going to be your best friend for that. Small droplet size.
Right. We have another question about the compost tea. Lisa's wondering, when you're making the compost tea, do the beneficial microorganisms survive or do they die?
So that's actually why you do testing. That's literally the whole point of testing the fungal foods, because you don't know what the consequences are going to be. And in my opinion, to be totally honest, I think extract is where it's at, because extract is just passing through all those microorganisms you made. Testing the fungal foods can take like a couple weeks. You're using extract. So that's like you're using extract while you're testing. Let's say you realize that you kill all of one organism group and you're like, oh no, right? Like I didn't mean to do that, but that's sometimes what happens with the different fungal foods. So teas are really just about adding food and doing additional testing. So I'd say if you have great compost, and we typically expect about a 30 to 60% extraction rate with our extracts, I would just make a compost. I would just make an extract because it's going to go further and it's less work.
Right. This is a lot of information. It's amazing. People are wondering about the handout. So Melissa had a PowerPoint, which I think people are interested in looking over again. So if it's okay with you, we'll get that, and then I can share that back out, probably via Eventbrite as a follow-up, since most of you, everybody registered on Eventbrite. So, and then there's one more question here about the name of the book by Dr. Shiva.
Vandana Shiva, yes. Actually, it's really amazing. I truly can't highlight it enough, especially since I'm just looking through my presentation, so I get you the exact specific name. She's been doing this for 50 years, so her perspective is unparalleled. I will go ahead and put it in the chat. It is Agroecology and Regenerative Agriculture, Sustainable Solutions for Hunger, Poverty, and Climate Change.
Right. Thank you for that. And then Marie, I think this question is for you. What about getting on the list for the free compost twice a year? How do people do that?
I put my email in the chat, and you can just email me. And if you're not in the city I take care of, I'll get you to the right people for that city. And usually your hauler, whoever your hauler is the ones putting on the giveaways.
And I know that in Benicia, Marie also does some newsletters that go out. I think it's in the bills. And do those go digital too, Marie? I know there's a paper version, but do they somehow go out? I don't know.
Yes. If you go to our website, so it'd be republicservices.com/Benicia CA, you can see all the brochures, all of the past sustainable Benicians with information in them. We always announce the giveaways, and there's a lot of good information on the new laws too, SB 1383, as well as the ones about no straws, and you're supposed to only have to ask for single-use utensils. They're not supposed to just automatically give them to you. So that's a new law too.
That's interesting. One other thing that I think would be worth mentioning, Marie, is you were talking about the little bags, the little liner bags you can put inside your compost bins, which I actually use because I feel like it makes it easier. I can just tie it up and then put it in my green waste bin, but I know that way you don't get spill everywhere. And that might cut back on some of the smell, but some of those bags are not really compostable. And there's a certain number that you need to look for. It's something like DSTM something. Can you explain that, Marie?
Yes, look for the ones that are 6400 series. So 6400. So it'll say that somewhere on the outside of the box when you purchase them. And some areas like Lareau, Recology does not accept bags. So you would want to use a paper bag or use newspaper, take the window out, use junk mail, any of that you can line your little pail with. And the best pails are the ones that have kind of all the holes in the top because they're aerated, and so those smell less too.
Great. All right, well, we are almost out of time, 3 minutes left-ish. Does anyone else have any questions, or did I miss any questions? Hopefully not. I think I got through all of it. I'm gonna kind of scan here just to make sure, but I know that you covered a lot of information. Oh, here's another question. How do you keep fruit flies on those little compost bins? Well, you must have something yummy in there.
Yeah. Freeze them, empty them, or put more paper in them.
Something that I used to do just to trap the flies is I put a little bit of, a little scrap of cantaloupe and maybe some apple cider vinegar in a mug, and then cover the mug with plastic wrap and poke little tiny holes with like a toothpick
Mhm.
in the plastic wrap on top. And what will happen is the little flies went in and then they couldn't figure out how to get back out. And it actually did kind of work. So I don't know if anybody else has ideas, feel free to throw them in the chat. We're all open to all of these little clever tricks. So
That is a good trick. I've done that.
yeah. All right. Okay, well, I don't see any more questions. I did repost Marie's email in the chat, mknutson@republicservices.com. So feel free to reach out to her if anybody has questions about the bins and anything else related to that. So I think we're good. Well, thank you very much, Melissa. This was a wealth of information. We are so happy that you were able to join us for this. And I will do a follow-up on the PowerPoint, and we'll put Marie's information in there too. So we'll share out all of this. And this video, this was all recorded, and so this will very likely end up on our website, and we'll send links to this too. It'll take a couple days for all that downloading, but we'll get it out to you guys.
Thank you for being here.
Thank you, Stephanie. Thank you, Melissa. And thank you for everyone that attended.
Yeah. All right. Have a good night, everyone.